Hi, welcome to the second lecture of Advanced Material and Construction. Today I would like to talk about Materiality 2.0 and its relation to fabrication, craft, and ornament, three phenomena that we observe with high interest in architecture in the past 2 decades. We saw this evolving relation on the last lecture between material and man, between the abstract and the concrete, between the spiritual and the actual, between man and nature. And this evolving relationship has led to a new understanding of materiality as we see it today, which I name Materiality 2.0, and we see it almost everywhere from philosophy or thought, lectures, courses, and also projects themselves, where material is taking central and dominant place in our architectural activity. And I would like to argue that this is closely related to fabrication, craft, and ornament, all three nurturing and vice versa this new understanding of materiality. Let's start with fabrication and its relation to materiality. For hundreds of years, actually since Renaissance, we have this perception of architecture and fabrication as two separate worlds, where we have the idealistic image of architecture as something estimated high, abstract, this lady or goddess standing and showing the drawing or the image to be realized in material. And on the other hand, we have the workshop with fabrication and the separation just getting higher and higher and stronger, obviously thanks to the tool of perspective and projection drawing that we have since Renaissance, which enables us to translate or to transform our concept into a drawing to be thereafter realized by other people on the field, in the workshop, transforming material into our desired reality. But when we have today a look at Google, for example, we just Google fabrication, we see that this is very closely related to structure and to architecture, and this occupies a central place in our professional activity. For example, we have these two conferences, Matter and Fabricate, with a very simple and straightforward name that exemplify that we are interested as architects in academic and professional activity, in fabrication, and in the way this is transformed through matter. And we can see this diagram of a process, an architectural process, which is a linear diagram with clear hierarchy going up from design by the architect, of course, thereafter to engineering, and to be resolved and actualized in manufacturing. So from abstract form, thereafter taking some structure and flesh into it by the engineer, and thereafter materialized through the actual construction or builder. Today, with the introduction of computer, we have a whole different scheme, because what is connecting these whole three stages of a project is actually the computer. And fabrication all the way to the end also involves computation and digital information. So as architects, it's no longer we giving orders that we transform by somebody else, but we have accessibility, we speak the same language, we have the same responsibility or the ability to affect our project all the way to an end, the responsibility to be involved from the form through structure to material. And this is no longer a linear process, but more an iterative process going over and over to final optimization and realization. So this appearance of fabrication in our world through computer is noticeable everywhere. You can see this architectural studio at the ETH, where we no longer have only knives and cardboard, but we do have robotic arms as the central tool for us architects to investigate, elaborate, and get our architectural piece and advancement in architecture, actually. A whole new vision of the architectural teaching and studio, and we see it also luckily today at the Technion with the thriving workshops that we have on the first floor, just inviting you as students and as researcher architects to go and explore with these tools. And an interesting review by my colleague Guy Ostern, talking about the rationalization methods in computer-aided fabrication, where he reviews all the different processes, digital processes of fabrication, alongside different materials which are being used. This review includes, it's a very vast one, including industry and academia as well, academic research. And there is a strong emphasis on the role of material, or the interest that is in the research that is related to material, as you can see here. So not only optimization of quantities, but also optimization of the process and of material itself. So we see that this material research that we are going to talk about later in the course is strongly related to this new procedure or discipline of digital fabrication in architecture. And with this new abilities of design and fabrication come an incredible amount of complexity. Complexity of number, size, variation, differentiation, relation to context, optimization, and whatnot. And with that comes a new intermediary discipline that we did not know before between the architectural conception and its realization. We have entities like design to production, for this example, which is kind of a studio that makes the architectural dream come true in a way. As they have written in their website, organize, optimize, simplify, materialize. So we have all this chain of events that will lead from a concept that is complex into materialization, and with a strong emphasis on optimization that is related strongly to matter. So we have a look, for example, in their website as a project. So the role of this intermediary, like design to production, as they say it, is to guide this route or accompany along this passage from concept to machine, or from design to production. And that's the essence of fabrication or digital fabrication today. For example, we see this Cambridge Mosque project where you have about 30 trees, wooden trees like that, that are an abstraction of lines crossing each other, and realized in CLT, in cross-laminated timber. Now, of course, when you have these crossing lines, these joints, you have to define how is this crossing taking place in 3D world. And with regards to the bulk material that you have, the specific material you're working with, and the CNC 5-axis milling machine that you're working with, your tool, you need to optimize all this to make the most of it and to make these 2,700 different pieces come true, come together, be fabricated in Switzerland and assembled on site in England. And that's the essence of actual architectural fabrication in these kinds of projects today. And that's the role, that's the management of complexity that should take part. So here you see the specific 3D joint in each and every crossing of these lines. You need to define how this 3D substruction is taking place with regards to material and machining limitation as a whole. A very similar project in a way is this time Shigeru Ban in Japan by Centigrade. And here again, the essence is these crossing. Here it's really made from almost scrap materials. It's just about a huge puzzle of more than 7,000 pieces, a 3D puzzle of these only joints. And its feasibility was thanks to the algorithm that you see here. So you have 3 generations of algorithm developed in order to make this project happen, or to minimize the waste, the material waste, the bulk material waste, in a way that this project could be realized. This is kind of a shelter. And of course, then data management of ordering all these elements for fabrication, which would not be the order for assembly on site. And that's part of the know-how that should be taken place. Elbphilharmonie of Herzog de Meuron is probably a project that we will see quite often in this course, because it groups together a lot of materials where material research, innovation, fabrication is taking place. And in this case, I would like to stop for a second of the interior of the main hall. Actually, the acoustic wall. This is considered to be one of the best, if not the best, concert hall in Europe today. And this is pretty much thanks to the acoustic work that has been done in analysis and in fabrication of these walls. So this is a specific gypsum board that was CNC milled. And when you have about 10,000 pieces, panels of that, we're talking about machine time that should be optimized and machine toolpath. You see here 1.5 million linear meter of milling path, and other figures like million cavities, all of them different, of course. So this interaction of a design or an analysis in this case that is then translated through fabrication knowledge and the material itself makes actually this encounter between sound and the material that gives the result that is in such high quality. Of course, not without the aesthetic qualities that goes along it, because we are architects. And in a way, we are participating in a machine. And this drawing or textile solution, which is actually Gary's, Frank Gary's company, of the design of Foundation Louis Vuitton in Paris, we see here a type of drawing that is a technical one, an engineering one, and that's a different vision of this same building, this huge architectural machine that we have, this ship, if you would like, that has landed in the middle of the forest in the western side of Paris. And this is the time to recall Le Corbusier in towards architecture. But in the blink of an eye, if a mass production state of mind came into being, everything would soon be underway. In effect, in all branches of building, industry, as powerful as natural force, invading like a river that rolls into destiny, tends more and more to transform raw natural material and to produce what are called new materials. So I doubt if Le Corbusier had this specific industrial evolution in mind, but of course we see this huge machine that we are taking part of, and this transformation of raw natural material in this mechanical process, this digital process that we as architects are participants and responsible of. And that's a new way of introducing the materiality into architectural world. So we'll not do a course about digital fabrication. We'll just mention the three lines, we would say, of additive manufacturing, subtractive manufacturing, and the line of robotics, which is a way in between. These are three paths of development where we put our most energy in recent years. And all of the thousands robotic applications that we can have in our field evolving, I would like to have a look at this application called Dusty Robotics, which actually does this connection between what we called before the lineamente, or the abstract part, the drawing, and the actual happening on the
I like the accuracy, but also the additional information that comes with the robot. So right now we're able to chase and solve those smaller issues several months before we normally would be able to see it.
The biggest value props that we bring to the job site is that we are taking the digital model that gets designed in the pre-construction phase, and we are bringing that out exactly literally into the field. And that accuracy gives all builders the confidence that they're building exactly what they're supposed to be building, and they don't have to come back and do any rework. Part of what we're doing is making the entire job site safer for people, giving them better working conditions, and creating better outcomes for the projects. Dusty is revolutionizing construction, both on the labor side as well as on the technology and the process side. Our vision of the future is a construction site that looks a lot more like a manufacturing floor than it does the chaos that it is today. And the way we're going to get there is by bringing more advanced robotics into the field, onto the job site, in order to make the work go a lot more smoothly, a lot more accurately, and also a lot more digitally.
So this vision of connection between the digital world and the actual world of construction fabrication, this is yet another step that we see here in robotic fabrication. And maybe moving forward to something that is more connected to our actual world of architecture fabrication, a quick view at the work of Gramaccio and Koller over 15 years now, where they have been specializing in these complex assemblies of very simple building blocks, starting from wooden chips and evolving to quite a lot of materials in robotic assembly, maybe more directly related to architecture. Years-long working process, starting from the complex assembly of simple bricks, starting with wooden simple elements, and they have evolved over the years with ROB, this robotic arm, creating complex spatial structures out of bricks. And they have evolved not only in surface textures and effect that they generate, but also in the materials they use and the process, the robotic process, and what it involves. Just a glimpse of the different textures and materials they are working with, from bricks to wooden elements, cross-laminated timbers, and even gravel. The principle of the flight assemble architecture of Gramaccio and Koller actually as the next step of evolution after we understand the abilities of the robotic arms, we see trying to merge actually what's happening in the world in terms of technology and mobility in space, and this time it's the mobility of the construction element. So starting with the material itself, developing the material to be able to integrate this system. Here you see actually the bricks prepared for the installation, then actually structuring the framework of the space. Here it is with the sensors that will direct this procedure. And once we have these two elements put in space, you can start structuring a structure that would not be feasible otherwise. Gramaccio and Koller think about this and on two levels. First, as the structure itself, and on a rather more futuristic level, as a model for an urban space on a much larger scale, where each brick could be actually a unit or a housing unit, which brings us back to other futuristic idea of the 60s of a metabolist architecture, maybe of the 21st century. And to conclude this part, this quick look at robotic fabrication and matter, I would like to have a look at this example yet again from the ETH, from a different research group, the eggshell column, or the future tree. And it is combined of two elements, both of them involving digital fabrication. Let's have a look what they demonstrate. We have two parts in this project. We have the top, which is a wooden canopy, and the bottom, which is a concrete casting. The canopy is actually an assembly. It's a reciprocal structure, a very smart structure made of very simple wooden elements. And the question here, or it demonstrates the tools of digital assembly and optimization. The bottom part is about a concrete casting, and it's additive manufacturing. The interesting thing is it's not for the element itself. It's not 3D printing of concrete as we know, but it is for its mold. And this is interesting for a few reasons. First, it's a very simple, quick, and cheap way of generating a mold, and therefore it can enable variation with no excessive cost. So that's one part of it. The second part of it is that this mold, once the element is cast, the mold is just peeled off. Meaning this enables a whole set of new geometries. You're not supposed to worry about undercuts and other things, limitations that we have with molds. So we have a freedom of geometry as well, and a very intricate surface, as you can see here. And finally, it's generated texture. This is a whole new surface kind that we get in concrete. And the combination of both is, of course, demonstrating the full capacity and the power of robotic fabrication and, of course, the digital tools for design today. And from this example of a project of the future tree, we can see actually two types of system demonstrating two development that we have in the field of fabrication and architecture. One would be towards efficiency, I would say, and that would include the integration of beam, integration of all systems, performance and simulation, construction and robotics, assembly, etc. And on the other hand, the line more tending towards the development of this practice as a craft, with an emphasis on matter, material qualities, and structure, as we saw in this event. So with that, I would move forward to talk about craft a little bit. Let's have a look at this exhibition that was held a while ago. And I like the title very much because it was about digital fabrication. And it was called Making a Difference and a Difference in Making. And it was about how the different way of making that we have now with the digital tools, with a broader look, can have an impact in all our surroundings and making a real difference. And this is not only about the artifact and the craftsmanship in the artifact itself, but more broadly, repurposing, recycling, hacking, education, conservation of digital heritage or traditional heritage, and empowering different parts of the society through these elements of digital fabrication. Some of you might know the Fab Lab International Network, which is exactly about that, about digital fabrication labs for the community as an international network to take society forwards by these ability of autonomized fabrication. And looking at this project, for example, of Unfold, so this is about the combination between traditional casting and 3D printing. And one can notice a very strong resemblance or inspiration from Art Deco structures and aesthetics of the 1920s and 30s, which is very predominant. And in a similar way, also this semi-romantic look with digital fabrication on former traditional heritage that we have. This time it's Amit Soran's work focusing on archaeology and this combination between reconstruction of archaeological elements, combining 3D scanning and optimization and 3D printing on the project on the left, and on Shiran's project on the right, development of on combination of high-end craftsmanship and woodworking, manual woodworking on one hand, and on the other hand, 3D printed nylon joints, optimized, that are calculated to take the loads and also introduce a new type of aesthetics into the crafted object. And we see this digital craft in various examples, taking the ability with materials to the extent through, for example, here, CNC milling of the material, and reworking surfaces that might not have been possible before, introducing new shapes and new aesthetics within this woodworking, this traditional woodworking of a luxury crafted object. And these new abilities of digital fabrication not only give us new surfaces, shapes, and aesthetic qualities, but also bring us back to values that we know from traditional crafts, values of aesthetics and of preciousness that are transferred through the material and its processing. And it is, in fact, a lot about process and time. Let's have a look at the work of Matthias Plessing and the multiple stages in the process that are involved.
Plessnig's benches start on the computer. Once he's got a shape he likes, he chops it into segments, using lateral cross-sections from the drawing to determine the shape of the first temporary ribs. He cuts those ribs out of plywood with a jigsaw, or has them laser cut by CNC. He props the ribs in place along a curving strongback and begins bending temporary stringers to shape and wiring them to the ribs. He calls these sketching stringers because he uses them like a sketch to visualize and refine the shape of the bench. From this point, it seems the bench is not so much being built as undergoing metamorphosis. It grows and sheds sets of ribs and stringers in a Darwinian sequence. First, Plessnig uses the sketching stringers as a kind of mold inside which to bend a series of temporary steamed wooden ribs to shape. With those new ribs in place, he removes the sketching stringers and steam bends final stringers to shape using the temporary ribs as a mold. When he's got about half the final stringers in place, he starts removing temporary ribs and bending final ones to shape inside the stringers. At last, these final ribs and stringers are epoxied at their intersections. There are thousands of face joints making an extremely strong yet light structure. At the open ends of the bench, and at intervals along its length, he laminates extra thick ribs, and where stringers cross those ribs, he reinforces the joints with pins made from bamboo skewers. Plessnig hand scrapes the whole outer surface of the bench and sands all the surfaces, inside and out. It was the challenge of building functional structures, Plessnig says, that engaged his imagination and launched him on this course. Building benches paired his passion for craft with his aptitude for innovative engineering, and he began creating shapes that were beyond beautiful. They were also useful and full of purpose.
Let's recall the beginning of arts and craft movement. We mentioned it before as a counter movement to the Industrial Revolution, and here we see again Williams Morris workshop and the Industrial Revolution that brought this auction all about. And I would like to talk about the meaning of craft through the work of David Gauntlett, a sociologist, with his book Making is Connecting. And it is about making. In his case, it is about digital media, digital platform, but I think we can take this to digital fabrication very easily. And what is Gauntlett saying is that actually through making, we have three different levels of connection that is taking place. The first and most immediate level is the connection of things and idea. That's kind of design thinking, if you wish. And because you are participating in a process, and we saw the process before, you are interacting, you are combining things, you have to make them work together, and then you are connecting what was disconnected back then in the Industrial Revolution and in the mass production process. At the second level, when you are making anything, most probably you will have to connect with other people, and that's the social dimension, because you are interacting in a system, you need some services, this thing is then operating in the world, and that's a level where you are connecting and you communicate and you connect with your environment. And the final level is the connection with the world, a commitment to the environment. Once you are dedicated to the making of something, you appreciate the value of any material element, and you are looking differently at your material surroundings and your material reality. So these three levels of making, which I kind of borrowed from David Gauntlett to the world of craftsmanship or digital craftsmanship, sits in this curve depicted by Gauntlet. He's talking about digital media and the passive approach that actually took place through the introduction of television. And with digital media and the active participation on platforms such as YouTube, for example, or any other social network that we have now, we have some kind of a promise of digital media where the person, the individual, the involvement of the individual could rise up from the passiveness towards an active participation and connection, as we saw before. So on that, we could also put our aspect of craftsmanship or digital fabrication with this decline of connectivity to people, to things, to the environment coming from mass production, and a rise with a possible, potential, optimistic rise that we can have with the active participation in the digital craft, in the DIY world, in the self-fabrication, in the fourth industrial revolution. All these are terms that are connected to describe what has gone through our environment in the past 20 years. And I would like to mention Ivan Illich, a thinker that in 1970 wrote Tools of Conviviality. He wrote a lot about tools and technology and the way this relates to the human. And he writes, tools are intrinsic to social relationship. An individual relates himself in action to his society through the use of tools that he actively masters, or by which he is passively acted upon. So that's exactly the level of connection that we saw before in David's Gauntlet. This is the action that you put through your tools or the technology, and you influence and you participate in your economical, sociological environment. And he continues, to the degree that he masters his tool, he can invest the world with his meaning. To the degree that he is mastered by his tool, the shape of the tool determines his own self-image. So here again, we get the responsibility and the ability to master a tool and by that convey our message, our influence, our participation in the reality that surrounds us. It's a privilege and an obligation. And this also introduces the discussion that we know already about the influence of the tool over the result. For example, a very well-known discussion about the tool that we choose, the CAD tool. Is it Rhino or is it AutoCAD? And the way this is reflected in the outcome, the morphological outcome that we have. Our interest in parametric tools that then enables us or draws us into this world of creating variation and adaptation in this parametric models that we can identify very easily in their aesthetics. So this connection between the tool and the result, and to the degree that this is mastered by the architect or the architect is driven by the tool he is using, this is a note very worthwhile taking when we talk about craftsmanship and the digital craftsmanship that we want to install. And this control of the material, the tools and the process brings us back to this foundation wheel of the Bauhaus, where you have the materials and their processing as the basic course, the basic starting of any design or creative activity. And I love very much these examples of, on one hand, the woodworking of James Karezov, the impractical cabinet making this extremely unique and rare pieces, which are, of course, impractical in their investment, but are a masterpiece. Same as this expression of Otti Berger about the textile designer of the Bauhaus, about the essence and the importance of the craft and what it conveys. And the digital craft is just another level added to that, and the variation and the richness that we can get from the control of the material, of the tools, of the technology is just similar to traditional craft that we see in this cabinet making. I would like to have a look at the work of Andrew Kudlas. He's been developing digital fabrication for over 15 years now in this very unique project of luxury and craftsmanship.
Working with Pierre Jouet has been very interesting for me because it provided a link between the historic Art Nouveau movement and my own work. One of the ideas that I feel very passionately about is digital craftsmanship. I think digital craft is very related to the Art Nouveau movement. There's this strong connection between design and technology at that time. I've been interested in how I could kind of look towards nature for inspiration. Even now, one of the interesting things about a curved line is that it represents continuous change. How would you make a strand in concrete? How would you make a strand in 3D printed plastic or other materials? So I tried doing this through a few different ways. The first is through the screen elements. So the idea with the screen is that as people see the screen from the outside, they can kind of get a glimpse of people's feet and legs moving in the background. There adds a level of privacy and seclusion to the strand garden. For the table, I was interested in how to use 3D printed plastic to not only produce a series of strands that kind of emerge from the ground to produce various heights of a table, but also at the kind of micro scale, how those tubes could be kind of woven out of strands themselves. So my trip to Epernay inspired me to focus on the materiality of champagne. For the ice bucket, for example, I began to look at how I could use the actual material of Chardonnay grapes and use a powdered form of that to 3D print the ice bucket. So in the end, you're left with kind of the liquid champagne surrounded by the glass, and then the solid grape skins 3D printed into the ice bucket surrounding that.
This beautiful project and this interview with Andrew Kudlas I think is saying very beautifully this connection between craftsmanship and technology and the way it relates back to our tradition of Art Nouveau, as he states it, and the curved line with all the aesthetic implication it brings until today. And we see that there is a very predominant aesthetic that is taking place gradually along the years as digital craft is evolving. We see a level of intricacy, of complexity, and elaborate surfaces that we didn't see before. Not only were we not able to manufacture those 30 years ago, but our society or our reality was not ready aesthetically to embrace those heavily decorated surfaces. And this example of the collaboration of Yoi Kusama with Louis Vuitton by the hands of Marc Fornes, another important figure in the landscape of digital fabrication and the connection to Rhino, we see the strong and the heavy ornamentation of the surfaces as the most predominant aspect of this installation. And we take it maybe a step back to a more mild expression. We see here concrete screens of this museum of Manuel Gautran at the turn of the century in Lille, where the extension of the museum lies within an area with a tradition of textile that is very predominant, although north of France is very heavily invested traditionally in the industry of textile. And Manuel Gautran is just making this lace. It's absolute lace of concrete, and this is the decoration or the facade, if you wish, of the project. And with that, we're going to move to the third part of the lecture, which is about ornament. And we see this new facades, new aesthetics rising in the 1990s already, maybe a reaction to postmodernism, but we should contextualize this maybe and go back to this. Because we were all shaped and educated by modernism. And we were taught that architecture is an abstract diagram, and we see this domino of Le Corbusier, where we just have an idea or a concept of a structure or a building, and that is the essence of architecture, these bare columns and plateau standing there as an abstract form, and nothing more is required. And from this interpretation of Toyo Ito, this abstract diagram of Le Corbusier taking place in the 20th century by the Sendai Mediathek, the plateaus and the bare minimum of a structure in a wide open space, we should recall Adolf Loos and his treatment to ornament, ornament and crime, abolition of any symbolic action, any icon, any message that is conveyed through the building, and developing to less is more, this saying that has been the foundation of our modernistic education, both in architecture and in art. Somehow we could say that bare is the new ornament in this kind of aesthetic language that is developing, where we are brought towards complete abstraction and minimalism in expression. And we are in this continuous debate in the past 2 decades or more, as we see here in this example of the garment in the fashion show of Victor and Rolf, two controversial creators working together. And this excessive piece of garment, with maybe 10 times more the fabric than necessary to create this dress, and over this non-functional piece, writing less is more, and of course with a strong criticism of this bare minimalism. So modernism has brought us towards structural tectonics and the importance in space and structure over any other expression. And we see this in Peter Eisenman taking over Le Corbusier in his abstract diagrams and architecture as an abstract diagrams. But we can have also a look at a parallel path that is taking place through these same protagonists of minimalism. If we have a closer look at some of their works, we see strong ornament, very rich textures and surfaces, not by graphics of any kind, but by the materials themselves. So through this architecture as abstract diagram, we do have some kind of ornamentation that is introduced through materials heavily decorated, very imposing and very present, rich materials, as we see here of Barcelona Pavilion on the right, and brutalist concrete of Le Corbusier on the left, and the textures and the shadowing that we get from these materials. And through this example of SOM, of Rare Books Library, we see the graphic presence, the strong graphic presence of this facade and the way it filters the light, which is just the rare marbles that they applied as panels for the facade, nothing more. So the strong presence of the skin is actually what gradually takes the focus and the interest over the years. And in this project of Toyo Ito of the 90s, we see already not only the graphic presence and the aesthetic presence of the envelope, but really the structural load-bearing envelope in that case, transferring most of the functionalities to this barrier that we have of the building's skin. So not only filtering climate, but also structure in a very aesthetic and ornamental way, one could say. And focusing also on the skin, we have this strong emphasis in latest Jean Nouvel addition to Paris with the Philharmonic, where you see very intricate work of pattern over the tiling of the element. You see the close-up here on the right, and the effect that this gives to the whole very massive building, kind of flock of birds flowing in the sky. Yet another level maybe of importance of the skin is demonstrated with this building from the Milano Expo. That was the Italian pavilion. And in addition to the strong pattern that we see of the surface, the outer surface itself, it has yet another role. This role is functional. This is not a regular concrete. This is a project in collaboration with Italo Cement. And the importance or the peculiarity of this concrete is that this is a material that decomposes carbon dioxide. So this is a material, a coating of the carbon, where the surface of the building actively participates in reducing carbon emission in the environment. And this is a novelty, yet another approach to the building skin, not only transferring message or introducing ornament, filtering environment, holding the structure as we saw in the example, but also actively participating in the filtering and in the purifying of the environment that surrounds it. So mentioning some function of the skin brings us to this book edited almost 20 years ago now by Musavi and Kubo called The Function of Ornaments. Already the title tells you that there is this idea that the ornament is first of all present in our architectural activity but has also a function or some functions. And it's interesting to have a look at the structure of this book. So it starts from the level of expression or intervention or presence in the architectural piece, from the deepest expression of the form or the structure going towards the surface of the building. And then it moves to subcategories of architectural material, what you have to work with for this expression of the ornament. So again, starting from program, which is almost abstract, to image, branding, cladding, and light as architectural materials that you can work with to express this ornament. And all this is to generate a list, a very long list of effects or sensorial experiences that we have once we are witnessing this building. And it could go from scalelessness to moiré to amorphous to many different effects that we would like to generate within our building. If we take an example, so from the building we've just seen before, the Yale Library, so the material, the architectural material used is cladding, and the effect is texturizing. And for each and every building analyzed in the book, you have the detail of how this effect is achieved. So in this case, it's a combination between the material, the marble chosen for the facade, and the fact that it's very thin layer of marble. So on the outer layer, when seen from the exterior, you have the pattern, heavily patterned actually, stone. And the interior, you get the luminous effect of the translucency of this material, exaggerated or amplified with the oblique three-dimensional structure holding the material and giving this impression of depth. Another project, just another example, also cladding, but here to create a pleated effect. So this is from Sana Sejima in Tokyo, 2003, and that's the Dior store. And here the effect that is generated is pleating, or this idea of a fabric over the facade. And this is also achieved with fritted glass and then vacuum formed polycarbonate panels on the inside. And this is the effect that you get from this double layered facade. So we see from the building listed in the books that we have buildings from the beginning of the century going all the way towards present days. And there is this action of revisiting ornament and reusing it in present days with present technologies, as we see here in this project of Herzog and de Meuron, one of the first projects, taking a very classical type of ornament, these drawings, and interpreting them on printed concrete, which is current technology. But what happens actually is that with this wish to generate a strong effect, we're moving towards a new ornament that is an immersive kind of ornament, an immersive experience that is generated for us as a visitor or as a user, if you want, of the space. Especially present in these types of projects of pavilions that we have many of here of Heatherwick, the British pavilion in the International Expo, where material, form and structure, everything is engaged to generate this experience that is all-encompassing, that is taking all of your senses together to an immersive experience in space. And moving forward with Herzog and de Meuron again, we see that this tactile sensation or tactile experience generated by the material is also present in other types of material like metal. We have this perforated and embossed metal, almost like a braille writing for your body to understand the space. And this is the sensation that you get from the building, some kind of translucency that is gradual, something that is maybe elusive. And yet another example, here generated by this combination of light and material with ductile concrete in this museum in Marseille, generating very special lace kind of facade that filters the light, and this is enabled not only thanks to the pattern but also to material properties of this concrete, a high compacting concrete that enables these very thin members of the facade and creating this structure. To conclude, maybe an additional very profound aspect of the ornament, another function of it if you want, is the order or the sign. So we know the orders, the Greek orders, the classical orders, 5 of them, with very precise rules of application or proportion, almost mathematical expressions of relations between the parts and their decoration. And what's interesting is that these Greek orders accompany architectural history all along. So from Renaissance, which is taking it back, to the days of the 19th century, where we have the neoclassical expression of these orders and the way they are integrated in architectural facade, almost as pastiche. And maybe the transition between the 19th century and its high decorative attitude we see here in Sullivan, transferring us to modernism, as we saw before. And let's have a look at Antoine's Picon text about the ornament, or the new ornament. And what he's suggesting is that the ornament gives us order. So the 5 orders is actually a set of mathematical operations, rules of action, or practical principle, a kind of rewarding framework for man and society to be applied. This type of suggestion represents perhaps the best way for architecture to demonstrate its political relevance. What we need today are rules, not styles. Rules that may help us to attribute meaning to our action. We're governed by rules. Architectural ornament can display its profound connection to cosmos and order. And we need this profound connection to cosmos and order, and we see that this theme of the order is coming again and again. So this project, this evolution of a project actually of Michael Hannesmeyer, started with digital fabrication by laser cutting of cardboard and layering it, moving forward to 3D printing. It's called the 6th order, and it's not only about digital tessellation of the surfaces to create very intricate ornament, but also about the evolution of digital fabrication. So from laser cutting to 3D printing of sand in a full scale, again, this immersive, highly ornamental environment to give you this sensation of order. Here maybe also tackling the question of order and disorder, and its more recent version, again, reworking the question of the Greek orders, is with 3D printing of concrete, as you see here, working these elements in yet another type of digital fabrication and suggesting not only a new revisited form of the order, but also a texture, the texture of the material itself, thanks to the fabrication process used. And with that, we conclude this chapter highlighting how new materiality is reflected through these 3 topics of fabrication, craft, and ornament as we see them today in the architecture of the 21st century. Thank you.